Welcome back to Intro to Formal Logic. In this video, what I want to do is show you how to use indirect proof. Now, indirect proof is kind of like conditional proof in that it's a theorem. It's something where it doesn't have a rubric like modus ponens, where if you've got the arrow and you've got the left side of the arrow, then you get the right side out. It's something that you do in a particular kind of situation. What situation? Well, pretty much over here I have on the board, here's all the rules that we know so far: arrow out, modus tollens, and out, and in, and the theorem, arrow in, or conditional proof. We try to do these things. If we can't do these things, we see if our goal is an arrow. And if our goal is an arrow, then we proceed accordingly. Indirect proof is basically the situation of when we can't do this and this doesn't work, go for this. So I'm going to do 3 problems on the board to demonstrate how we do it. So let's start with this. We've got 2 premises here, not A, arrow B, and also not A, arrow, not B. Can we do an arrow out? Nope. There's no not A anywhere by itself. Can we do an and out? There's no ands that we can do together. Can and should we do an and in? We can do one, and that would get us this and this. That doesn't seem to get us anywhere where we want. We want just A by itself. That's what we're solving for. The next question that we've done so far is this: is our goal an arrow? And if it is, we provisionally assume the left and we get the right. Is this an arrow? It's not. So based on what you know now, you'd be stuck. Can't figure out exactly what it is that we need to do. Well, here's what you do. Indirect proof. What do you do in an indirect proof? You make a provisional assumption. But whereas in a conditional proof or an arrow in, we provisionally assume the left side, and then we try and get the right, what we do in this situation is we provisionally assume the contrary, or more colloquially, we can say opposite. We provisionally assume the opposite of whatever our goal is at the moment. That's the first step. So right now here, our goal is A. We're going to provisionally assume the opposite of that. What would be the opposite of A? Not A, as a provisional assumption. And I'm going to put here just marginally, this is a provisional assumption for an indirect proof, not an arrow in. So in an arrow in, we provisionally assume the left in order to get the right of an arrow, whatever arrow our goal is. In this case, what we do now is our mission. Once we do this, think of a provisional assumption as I'm starting a particular kind of quest. When we're doing an arrow in, we provisionally assume the left, we get the right. That means then we can get the arrow, if we can do that. In an indirect proof, what we're doing is we're going to provisionally assume the opposite of whatever it is we're trying to prove. And then we're going to look for any contradiction whatsoever. Any contradiction. Once we get a contradiction, that means we're golden. We're good. And here's why. What's going on in an indirect proof, or it's more commonly called, well, maybe not commonly, but it's also called a reductio ad absurdum, is what you're trying to do is this. You're saying, if the opposite's true, it leads to something ridiculous, namely a contradiction. Contradictions are crazy. This is a marker and it's not a marker. Assuming I mean that at the same time and in the same sense, that's a contradiction. So we look for any two, again, I'm going to say more colloquially, technically it's not opposites, but I'm going to use opposites because I think it's easier to understand at least from a rudimentary level. That's what's going on here. I'm looking for any two opposites of each other that I can then stick together with an and. If I do that, I've proven that this is ridiculous. And if this is ridiculous, that means the opposite is true. So, what we do now with this provisional assumption here is we go back to our regular order of business, trying to get any contradiction. What does a contradiction look like? Anything and its opposite. It could also be something bigger. I could have A and B, and not A and B. Both of these are contradictions. It's something and not that same thing. So sometimes we'll say things are contradictions when they might be incompatible, but not necessarily contradictory. Maybe a contradiction can be implied. So saying, hey, it's raining today and it's sunny today. Hey, that's a contradiction. Not necessarily. The opposite of sunny is not sunny, not raining, because it could be snowing, it could be something else, I suppose. And also it could be happening in different parts throughout the day. Something is a contradiction when it is explicitly stating something and its opposite in the same sense. So that's what you're looking for in an indirect proof. Once you provisionally assume the opposite of your goal, get any two opposites, and you might have more options than one. Get any two opposites and stick them together. So now with that provisional assumption there, let's do this. Now can we do an arrow out? Yeah, we can do 2. This not A that we're provisionally assuming is on the left side of both these arrows. That gets us arrow out, we get B. That was 1 and 3. We can also do another arrow out, this right here. We get not B, arrow out, 2 and 3. Now have we done all the arrow outs we can? Yep. Are there any and outs that we can do? No. Are there any and ins that we not just can do, we can and in anything when we have more than 2 or more things. Are there any and ins that we should do? Actually, yes here, because I told you, once you start a provisional assumption for an indirect proof, what you want to do is get any 2 opposites, again, technically contraries, and stick them together. And when I say stick them together, I mean add and join them, that is, use and in. So look around now, do we have any 2 opposites that we can stick together? We got B and not B. Let's put them together. B and not B. And in 4 and 5. That means we have just completed an indirect proof. We have said, if not A is true, it leads to a contradiction. That is, if this were true, it would lead to a world of absolute ridiculousness. Up is not up, and down is not down. Left is not left, and right is not right. Okay, and so forth. So we're saying if this were true, it would lead to technically absurdity. So because of that, we therefore know that the opposite thing that we were proving, if it leads to absurdity, that this is true. How do we know that? Indirectly, we have proven it, and then you just say the spectrum of what you've done is, where did you provisionally assume the opposite? In line 3. Where do we get the contradiction? Line 6. And that's how you do an indirect proof. Now, in the next video, I'm going to go ahead and clip this one right here, but in the next video, I'm going to do these 2 problems here as well.